Okay, so welcome to 6950 for May the 17th, class number 3. The main topic today will be some Python scripting. But before we get into that, my expectation, my plan was to take up assignment number 2 on Bash shell scripting. And as I just put out on in the Slack channel about 45 minutes ago, at least as of an hour ago, I only had submissions from about a quarter of you. So what I was expecting was A, you to do it, B, you to submit it as a private Git repository, and then number 3, send me a note on Slack saying, hey Prof, hey James, I did it. So saying that, in the last 25 minutes, like 4 of you have very quickly sent me a link saying, oh, I'm done, here it is. Try and connect these things, and a few of you are solving some problems. That's great. But I'm concerned that taking it up right now might be a bit premature if not everyone has done it. Completed. Okay, hold on a second. Assignment 2. Okay, we'll just do a little survey here. Save. Okay, I'm just going to do a little poll just to see where we're and don't worry about marks. It's just like, are you done? And you're like, I've done it, I've submitted, I can talk about it. Or you're like, no, I'm not quite ready for whatever reason. Okay, 17 out of 18 people. That's actually really, really good. I'm happy with that. Yay! Okay, fantastic. This is what I was expecting. This is what I was hoping for. So we should proceed. It was due today. I think the best thing is to continue with it. So let's take up assignment number 2, right? So assignment 2 is basically you trying to do something with the shell and investigate a few different things, referring to the online notes where needed for shell scripting and trying to figure it all out. Okay, so you've submitted what you've submitted up online. If you still haven't quite done it, I'm not going to really care if you submit it like the end of today, tomorrow morning, end of the next day. As long as you're submitting your own work and you're not like submitting the answer of somebody else, don't worry about that. But I do want to take it up because it's sort of been a week since we looked at this stuff. And the way that I'm going to take it up is how we're going to do participation in this class. And so roughly speaking, there are 21 people taking the course. There'll be about 7 or 8 assignments. So what I'm looking for is 3 people to sort of go through parts of your assignment. And of course, if you don't go today, that means I'll have to pick on you some other later time. So this is a fairly easy assignment. It might be a good time to get that done. So you can just sort of we'll do it this way, on Zoom, you know how to do reactions? You know how to raise your hand? I'm looking for 3 volunteers who can talk to the class about assignment number 2, what you did. So I'm looking for like 3 hands to pop up in the raise hand feature of Zoom. And so what I mean is you go to like, I don't know, there's a couple ways to do it. Look at the participants list. Oh, stop sharing results. Stop sharing the results away. You put this, and somewhere in here, is there not a raise hand in? Oh, whoa. Okay, there they are. You all figured out the side. I couldn't figure this out at R. Okay, so just somewhat randomly, and it's however it's showing up to me. Emmanuel, Yashar, and Brad. Great. Well, we'll just pick you three because they're at the top of my list. So this is more interactive. This is a class. While I'm lecturing, we don't really need to have mics open, but now would be a great time for some people to turn some cameras on because you're talking to each other. You're not really talking to me, you're talking to each other. So if you do have cameras, it'd be great if you turn those on, especially Emmanuel, Yashar, and Brad, but everyone else, because it's always good to see who's in the room with us. Let's do that. Oh, there we go. Thanks very much, Yashar. Thanks, Mike. This is good. I can see some faces. Talking to a room of names is really challenging as a presenter. Talking to faces, a little bit easier. So thank you very much. Okay, there's Khaled. There we go. 3 out of 17. We're getting there. Okay, so here's what we're gonna do. The assignment, what I asked for is what? There were 12 questions. So basically what I want to do is have the three of you, Emmanuel, Yashar, and Brad, and I'm just picking at you because you're top of my list when I saw it. There's 12 questions. Let's just do a nice round robin, okay? So what I'm looking for here is for you to share your screen, show me whatever text or block of thing you put in your assignment to, say this is what question 1 is, and this was what my answer was. If it's obvious, we'll just go to the next one. And if there's any questions about it, we'll ask those questions and we'll go to the next one. I said, Emmanuel, Yashar, Brad, Emmanuel, Yashar, Brad. And the idea is to spend about 15, 20 minutes on this. So that's the plan. So Emmanuel, thank you for sharing the screen. So what was the first question and what did you do to answer it?
Okay, the first question was how many earthquakes are listed in the table? So I used the word count for the file, and then I cut it from 1 to 4. So that gave me 5959.
My only question about that is what does -C124 mean for the cut command?
Give me a sec. I'm selecting just some columns. So I'm cutting
what does it extract?
Hold on a sec. Okay, so the first 4 digits, rather. I'm so sorry. The first 4 characters.
The first four characters, right?
Yeah, so 4 characters. Yeah, the first 4 characters. So without it, it would have given me a bit more text.
Right. So without that, you get that in the file. So it's the first 4 characters. Yeah, okay. Now here's my only. Okay, this is good, but this is why I want to talk about this. Before you type in that command, you don't know how many earthquakes there are. So what happens if there was only if there was 10,000 earthquakes?
So before I typed in which command, this one, the first one, before I typed in the, give me a sec. This one or this one?
No, the one we're talking about, the WC-L signif txt cut command.
Okay.
My question to you is,
I couldn't tell the number of rows. So this is just a row count.
But it is a row count, but the way you've answered the question is you have a cut -C 1 to 4. And what I'm asking you is, what would your program, your line of code do if there was 10,000 earthquakes in the table?
It would count, so WC is counting the line. So it would count 10,000 lines. And then I'll cut out the extra text, which is the file name.
Right, but if there were 10,000 rows, what would your program do?
I'm guessing it would, I don't know. I'm not sure I understand the question.
Okay, you know that WC counts the number of rows, right?
Yeah,
I'll make it easier.
Lines,
let's say there was 1,000,000 rows in the file.
I mean, it would delay a bit, I guess.
Yeah, so you're not following. When you have a million rows, WC-L will say 1 million space signif.txt.tsv.
Oh, okay. Yeah, okay.
And if you cut out the first 4 characters from a million, you don't get a million.
Yeah, okay. So I have to count the number of digits, and I figured the number was 4. That's why I cut out 1 to 4.
Well, that's right. But see, you don't, when you're coding, you don't know how many digits there's going to be until you know how many digits there's going to be.
Okay.
Right?
Yeah,
so the solution here is when we're talking about something that's in columns, what you want to do is you want to focus on fields.
Okay.
So cut has this idea of a field, okay? So -F1, -F2, -F3, you want the first field of that file, of that output.
Okay.
Do you understand that?
Yeah, so instead of C, I should have used F.
F1, yep.
F1, okay, which is the first field.
Yeah, exactly. And that's just because you're assuming you know the answer, and you don't. Okay, great, fantastic. Next one on. Yashar, what was number 2?
Hello, Professor.
Just let me share my screen.
Sorry
Thank
to
you.
interrupt. Hello, Professor. Can you hear me?
Yes, what's going on?
So sorry to interrupt. I have a question regarding the first question. Like the answer is 5959. But shouldn't it be 5958? Because he is also counting the header. The header is not an earthquake.
That's a very good point. So Emmanuel, how would you fix that?
Yeah, so the last row in the table is empty. So if you look at the data itself, there's an empty row at the end. So I don't know if you can look at it. Let me see if I can get it open. The last row in the data field is empty. So it's actually 5959.
Right, but you need to ignore the first couple rows in the file. The header row is not one of the earthquakes.
Yes. So but for this data set, the header row, I would have ignored it, but the last row is also empty. So it sort of cancels itself out.
No, it doesn't cancel itself out. It makes it twice as bad.
Okay.
You have to eliminate the first row and the last row from the count.
Okay.
Yeah, so that's correct. That's another error with it. And anyway, so these are exactly the things to comment on, right? Just to be aware about it. Excellent. Number 2. Yashar, what's going on here? Number 2. What was the question?
Sure. Can you hear me?
Yes.
Perfect. So I guess the second question is the number of columns, right?
Sure.
In the data set. Well, because there are some missing values on each on some of the data. So what I did, I took out the header, right? Because we know that all the fields are present in the header, right? And then the word count works on, I guess, on the if I'm not mistaken, on the space, like the blank space.
That's a good question. I don't know which one it works on, but okay. I think it could be the same.
So what I did, I just basically I replaced the tab with the space, the blank space, and performed a word count on the header. So then I got the number of the fields. I haven't included the output of my command. I don't know if I need to do it.
No, you don't need to include the well. It is generally helpful to include the command and what it produced.
Sure. Yeah.
Right?
Oh, yes. I'll change it. I'll change it later.
Yeah. So we just know what the answer is. But sure, that's a great solution. And these solutions aren't unique, right? There are other ways of taking something and splitting it up. But great solution. I have no problem with that at all. Any questions about number 2? Going on, Brad. What's number 3?
Can you hear me?
We can.
Okay, I'll just open it up here. The question was, yeah, we just had to cut the 3 columns into a separate file, I just used cut dash F and then just chose whatever columns corresponded to the year. Hold on, I can't see because of the thing. The country, the earthquake, and then the year. And then I just funneled it into the actual file, like the one that
Exactly. So what cut is doing is it's using, I think it's using tabs as the default way of separating out fields, right? And because this is a tab separated file, this works great. That's exactly right. No problem at all there. And I like how you demonstrated using head to show us the output of that as a good demo of it. Fantastic. Okay, rolling around again. I guess it's Emmanuel. You wanted number 4?
Okay, so number 4. So I used the cut to cut the first 3 fields from the file, and then I sorted it. But then I used the K flag to sort the second column, which is the magnitude, so it doesn't sort.
Nice.
Yes, and then tail, because I sorted it I think in descending order, so I had to pick the tail, which is the top 10 from the bottom.
Yep.
That would be so that would be the highest ones.
Beautiful use of sort. So how did you go about learning that you could sort by the second column?
Well, when I was sorting it was sorting the years at first, and that wasn't what I wanted. So I actually had to look for a file online, website to understand the flags that can help you sort. And then I came across K as a sort flag. So with K and R, so I could actually do R to RN.
Okay.
And I would have sorted it in the reverse order. So I would pick the head 10, so the top 10 rather than the bottom 10. Okay,
so your solution to figuring this out was to, did you say Stack Overflow?
No. I had to look for other resources to understand all the flags I could use with sort. I couldn't find the flags in the material you made.
You looked up the documentation for sort.
Yes, so I could get all the flags I could use with sort.
Okay, and that's a reality. Is these programs all do probably something, but it's worth looking at the documentation to figure out how they work to give your answer. So that's brilliant. Excellent. Okay, number 5.
Okay, that's me again. Just give me where is my, all right. So number 5, how many unique countries are listed in the database? So what I did, I first singled out the country column, and then I sorted the unique values over which I performed a line count. I guess that's fairly easy.
Yeah, I think you are right. So I guess sort.u is the same as sort of doing a sort and then passing it through a unique.
Yes, exactly.
Okay, cool. Yeah, so I said a lot of these functions, I don't remember when sort.u got added to it, but that's a good solution. I like that. You're asking a question, right? I want a column, I'm going to sort it, and I'm going to count it. Nice example of piping throughout things. Wonderful. Number 6.
For number 6, we just had to use grep, and there's USA and USA territories, so you can just specify USA, and then perform a word count on it just to get the number of entries.
Yeah, and whether or not you put a WC-L on that or not, it wouldn't have mattered. And I agree that the idea of grep. We'll talk about regular expressions sometime later in the course, but basically you can think of grep as doing a pattern search, right? You're just looking for the pattern USA. So exactly, because USA matches those two strings, there are 294 records in them. I think that is just fine. Sweet. No other comments on number 6? Number 7. The first half were easy, right? They get harder. But number 7.
Okay.
So we're back up to the Emmanuel again. Okay,
Okay.
what's number 7?
Number 7. So it's just an extension of number 6. So we're trying to just okay. So one just the US, not US territories, right? So there's a flag
Yeah.
with V. This flag dash V. So what it does is it's sort of pulls out a list that doesn't have. So it's sort of like a negation that doesn't have this. So we first do what he did with grep with the word US. So that will give us 294 entries. Then we'll exclude the territories. So that gives us 225. And then a word count.
Nice. Nice. So here's a question for you. What's the output of grep? Like I see you're doing a WC-L, but what does grep print to standard output?
It's the list of all the entries that has the word US.
It's all the lines that have it. It's the complete line.
All the lines.
Right?
Okay.
So it doesn't just extract out the words USA. It extracts out the entire line, right?
Okay.
So you're getting the lines of the table filtered by record, but you're getting the whole record, so you can still filter on another column, which is great. I think that would work just fine.
Yeah, it did. The outcome was 225.
Perfect. Okay, number 8.
All right. Number 8. Number 8. The question is compute the total number of earthquakes in each country and then display the top 10 countries along with the number of earthquakes. So again, what I did, I first singled out the country column and then sorted the values to be able to perform a case sensitive count on the unique values. I guess all the countries are I think in uppercase, but anyways, I did the case insensitive. And then again, I sorted the count in descending order to be able to extract the desired result, basically.
Right. Okay. So I'm going to ask a similar question. What's the output? So the output of sort is just the lines of the file reordered into ascending alphabetical order.
Yes.
Right?
Yeah.
What's the output from unique?
You mean the first sort?
Yeah. So when unique is printing the standard out, what's it actually printing to the screen? What's being piped into the sort minus R?
That's numbers, right?
Is it just numbers?
Let me see. No. This the numbers just side by side the countries. I don't have the my console right now, but I think that's what I saw. Yeah.
Right. So what unique does is it includes the count of whatever it sees and then the content, right? So it's number space content, right? So when you're doing the sort R, you're sorting on the full record, which is a number at the beginning. That sort -R, I see it's a reverse sort. Are you sorting numerically or alphabetically?
Oh, I guess the default is, I think you have to use the -N to have the numerical sort.
Yeah.
So I don't know what the default is, but I think it worked on my machine. So
well, I would be suspicious of that because when you do the count, I think alphabetically, right? Like 6 occurs.
Yes, I do understand.
16.
I do understand what you're saying. Yes. Yeah, you might be right. I thought that the default is -n, but probably you're right.
Yeah.
I'm gonna double
I
check.
thought you needed a -n in there to be able to make it work.
Right.
And Brad says, I think you need to use the -n flag because there's missing column entries. I don't know about that. Because what column are you sorting from? You're sorting on, yeah, you use -nr. Okay, so we do need a -n, right?
Yeah.
So again, so when you're using these pipes, just think about what's actually coming into each one of these functions and what's going out. Great. Number 9.
Number 9, you just have to basically copy and paste that into a shell script, and you can just put at the end, you can just pipe a grep and then just put $1. So it's basically using user input. So then when you run the script, you can just say in quotes like what you're looking to actually grab with grep. So then when you do that, you actually get the output of USA and USA territory separately.
Okay, so I get that it's very similar to the previous program, which like it's the previous program put into a shell script.
Yeah.
Right?
Yeah, you just put that extra flag there to actually,
right.
Just to grab whatever you actually put in as the input of like whatever you're.
Okay. So the $1, you understand that's the first parameter, right? So it's what's being passed into the program. Is it necessary to put quotation marks inside?
You don't need them. No, you don't actually need them. I just didn't take them out after.
Okay, but you do need them.
Technically, do you? I thought you could just have the $1.
No, so imagine if you had said, count earthquakes, USA territory. So if your argument has a space within it, that's why you need the quotation marks.
Right, okay.
Okay, so the reason we put quotation marks around the $1 is because from the point of view of the script, it doesn't know whether or not that variable has a space or not.
Okay.
Okay, so we put the quotes in there. When you actually go to call it, where you've said count EQs SH USA, right? It's not a wrong thing to put a quote around the USA. You just don't need to because USA doesn't have a space in it.
Right. Okay.
Isan, you asked a question. I used read-p in my script. You can use that. So what you did is you read. Did you use a? So I'm referring to Isan's comment in Slack where he said he used read-p. I'll ask you this, Isan. Were you doing this as part of a loop? Like, how did you use read-p? Oh, hold on. He's giving me the code. To get the input. Okay, so here is something about general using the Unix shell and in fact programming. I get that in very elementary programming, we learn input output, like ask the user a question, get an answer and type it in. In practice, don't do that, okay? Because you're gonna wanna have this program being called by maybe another program, which is called by another program. So anytime you have a program which asks the user for input, like in the way you've done it, by answering a question, it makes it difficult to reuse your program inside of another program. So we should not be, like read has a role if you wanted to confirm something, right? Confirm, are you sure you want to delete this file? But generally when we're writing scripts, use the command line arguments, the $1, $2, $3, because that allows you to have a piece of software or a piece of code that can be reused later on. Is that okay, Isan? Okay, fantastic. Okay, what number are we up to? Oh, that's an interesting solution, Mohammed. I guess that would work. Whoa, what's weird about that? The space at the end is a little bit. Mohammed, I think that's fine. It's match this, but don't match it with a space. When we learn about regular expressions, you'll see a cleaner way of doing that. But I see what you mean. Yeah, I'm having exactly the same hesitation, Brad. The space in a grep is interesting, but it will work in this case. That probably can be done better with a clearer regular expression. Okay, awesome. Let's keep on going. We're nearly done. We're on to, I don't even know what number we're on to. The next one.
10.
Okay, number 10.
Yeah. So so this is what I did for number 10. I use an echo to total number of earthquakes. Then
nice. Yep.
The grep W to get, then the $sign to take the input of the town, and then the file, and then a word count. So this would give me the total number of occurrences for each country. Then the largest earthquake, we did the cut with the flag F for 2 and 3 for the fields 2 and 3 for that file, and then we use the grep to get the word, whichever word we want to use, and then a unique count, and then we sorted the second column recursive by dictionary word, and then we took the head, which is the first file, which would give us the highest value.
Okay, so can you tell me what in the sort, the dash K, I know what that does, dash K2. The R, what does R do?
It's to sort in the order, so the recursive to sort the other way around. So instead of ascending, sort in descending order, you sort from the highest one first to the lowest.
Yeah, so it's reverse the sort, not recurse the sort.
Okay.
Reverse the sort. Okay, because recursion is a different concept. And then the D, you said by dictionary sort?
Yeah, dictionary words. So I'm sorting it by words, not numerical.
And why don't you want to sort it numerically?
Why don't I want to sort it numerically? Why didn't I want to do that? Why didn't I want to do that? I'm not, honestly, I'm not sure why I didn't want to do that.
Okay. It's possible.
That work as well?
I'm not sure, because the thing about, I have to look at the documentation. When it's doing numerical sorts, I don't know if it's sorting on integers or can handle floating point numbers. Right? We can just try it, right? The dash n.
Yeah, it does the same thing.
It does the same thing. So I'm not entirely sure why you said dictionary sort. It won't really matter because for this sequence, because earthquake magnitudes are always an integer dot something.
Okay.
I think in this particular scenario, dictionary sorts and numerical sorts are going to end up being the same because of the nature of the magnitudes. They're always that sort of order of a number dot a number, right? They don't have any more digits. So a dictionary sort will always sort in the first digit, then the period, then the second digit.
Okay.
Right. I guess yeah, nice.
Yeah, so because you mentioned it, I guess in the question.
Okay.
So so what I did again, I singled out the year column and then sorted the values to be able to perform a count on the unique values. And then I sorted the count again in descending order to extract the desired value, the desired result, I mean.
Exactly. So you're chaining these things together. So there's the list. And so the point is with these and use the sort function. Like there are other ways of doing this, but the point is in one line, you can get your answer. So if your data is in a table, you don't need to bring this into a piece of software like Excel to sort it, make it unique, and count it. They're one-liners. And as you get faster and faster with these things, you can even make these shorter, right? So we've already learned that sort and unique-c, I think you can just say sort-u, and that will make it even tighter. So
right.
There are ways of making these things quick things to ask and to get answers to, which is why we use the shell, right? It's good for data exploration. Okay, one last question, and we'll move on to something new. Brad, what was the very last question in this intro to Bash assignment?
The last question was to just create a shell script that loops over the 10 years with the most earthquakes, and then just output them to separate text files based on the year.
Okay.
Yeah, so I just set up like a simple for loop and called in basically the answer from 12 as as like a variable, and then just grabbed that variable and then funneled that into a text file dependent on that variable. So you get 10 different text files for each year.
Okay, so year is a variable. So you're demonstrating the way of taking the output of a command and putting it into a variable. I like that a lot. You're sorting, then you're uniquing, and then you're sorting. This is one we haven't talked about a lot. What is AWK?
That's awk. So you're basically just grabbing something from basically whatever you're piping at that point. So I was just grabbing that year.
You're grabbing the second field.
Yeah, and then I just took the head and then the tail of head of basically whatever part of the loop we're in, and then the tail just to cut it off. So we're basically looking at the first, the second, third, fourth, etc.
Okay, so that's like what you've done is totally fine. But here's something in terms of making this code readable. In the beginning of that line, you use cut to select out the first field.
Yeah.
And then halfway through the line, you're using awk to get out the second field.
Yeah.
You could have used cut for both.
Twice. Yeah, I could have used cut twice.
Yeah. And not that it really matters, but you can imagine someone reading your code, right? They understand what cut does, and now they're in a new line, which is something different again. So like awk is standard. It will always be there. It'll work just as fast. Just think about what that code would do for doing it. Okay, one more thing about this thing. You got a script. You have a loop. I like the use of the loop. What would happen if I wanted not just the years? What year? So the N, capital N.
Yeah.
Right. What if I didn't want those years? I wanted a shorter list of years or a longer list of years.
Well, you could cut, if you wanted less, you could cut this down, or you could just set this up as like a set or like an interval. I couldn't remember how to do that in Unix, so I just wrote them all out. Okay,
and that's what I'm getting at is what's the command for making a sequence?
Yeah, it's like
the command is sequence, SEQ.
Okay, yeah.
There's a program called SEQ that what it does, if you say SEQ 10, it gives you the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you say SEQ 3, 8, it'll give you 3, 4, 5, 6, 7, 8.
Okay.
No problem. As long as you knew that. Listen, there's always a trade-off, right? It's only a short little program. You don't be spending half an hour writing a program to write it, but there'd be no things. Okay, excellent, fantastic. You all get your check mark. You participated. I think we've covered all the solutions. I will go through and make sure you've done it. Most of these assignments, I'm expecting the marks to be incredibly high. They're basically participation. Have you done it? Have you looked at it? We will try and get back to some bash stuff, but I think you've got at least a functional understanding of loops and variables and scripts, and working with the command line. We can move on to something new. So in the topic of moving on to something new, I want to move on to a scripting language, which is not bash, a scripting language called Python. Okay, so Python. Python has, so it's been around since the 90s. I started using Python professionally in about 2005. I was a PhD student, and my supervisor was using bash scripts. No, I lie. He was using C shell scripts and this obscure scripting language from something else. And I went, that's just as horrible to read. I want something new. And as students everywhere, we tend to just spend an inordinate amount of time learning something we don't need to learn about. Turned out it was a good bet because I was able to say, hey, Python is really cool before it was cool. So 2005 is when I really got into it. So I've been doing it a few years now. In the intermediate years, Python has been one of the dominant languages in data science, in scientific analysis, for working with quantities of data. It's a fairly readable, expressive language. It's not the only one out there, depending on your field of research. There's a language called R, which serves a similar role, especially in the biosciences, statistics, ecology, digital humanities, which you should keep in your toolkit as well. But Python really has sort of shown its power to be able to do most things that people need to do. In particular, there was a software environment called MATLAB, which for a number of years fit the role of being easy to program in, doesn't have as much overhead for the user as, say, a C or a Fortran, but it's expensive, right? If you actually have to buy a license of MATLAB, it depends what you're working on. Like as a student, you might be able to get it for free, but if you're a professional wanting to use MATLAB, depending on the circumstances, it could be like $2,000 a year to pay for the contract of MATLAB. And so if I say Python can do everything that MATLAB can do more than MATLAB can do, and by the way, it's free, that goes a long way into looking at its adoption. So what I'd like to do is talk about Python, give you some information about the language. The reason is there are so many libraries that people use out there to do data manipulation and do sort of the scientific process. It's something useful to know about. We could do this for any scripting language, but it's the scripting language I'm going to choose. Now, some of you may be Python experts, and well, then this is just going to be review. Take this time to dig into the subtleties of the language. If you are new to Python or new to programming, this will be right up your alley, because we're going to sort of go from sort of first principles. Okay, so what do I mean by first principles? We'll do a couple of things here. So I'll just share a screen. Okay, so a very slow computer and a web browser. My internet connection is unstable, but that's why I'm talking to you through a phone. Okay, so what we're going to do is we're going to look at a guy named David Beasley. David Beasley is a longtime educator and software engineer in the Python space. Among other things, he is the author of the Python cookbook. So he's been an author and a writer in this space for a long time. And just last summer, he rolled out a open source course based on the stuff that he's done on Python, and he called it Practical Python. And I went through this and I went, that's the right content. This is a really good resource for looking at this information. And so I'm going to use this as my resource basically to guide us through the essentials of Python. Now, there are dozens and dozens of books, websites, courses, ways of learning this language. I just happen to like the way that David Beasley approaches this. He's released this under a Creative Commons license, so as long as I give him attribution, which I'm doing right now, we're fair to use this. And his attitude towards it is very much my attitude towards it, right? He was immediately struck by how productive he could apply it to a whole bunch of different messy work projects. And it's now used all over by traders, sysadmins, astronomers, tinkerers, and rocket scientists, right? Is sort of the group that it uses. Okay, so what I want to get to is to take me to the course already. And if you're following along, this is the web version of the course. So it's just a web page, right, in terms of the contents. Okay, what I'm hoping you have done, if you read the Slack message from yesterday, but maybe not, is you went to the course setup and you took a look. The course setup says you need a few things. One is we need a basic Python 3.6 installation or newer. Now, if you have set up your environment and you are on OS 10 or Linux, almost for sure you've already got this. If you're using WSL and Ubuntu, you've already got this. And from assignment 1, I don't think there's anybody who's doing ways of installing Python. You can go to the python.org website. You can install things from something called an Anaconda distribution. You can get it packaged by different people. We're not doing any of that. We are doing sort of plain vanilla, traditional Python. There are no third-party dependencies in what we're doing right now. The way about this particular author's way of teaching it is we're really learning about how to program in a command line environment. There are great tools like Jupyter Notebooks. I love Jupyter Notebooks. I use them all the time. For the purposes of this introduction, we are not using notebooks. We're going to do things on the shell in the terminal and editing files to understand what's going on. To set us up, what you're going to do is I want you to have created your own fork of this course. Okay, so what does that mean? And if you've already done this, great, just nod your head. If not, just pipe up and make sure we got that. So he's released his course onto GitHub. And this is one of the reasons I wanted you all to have a GitHub account. And so here's the course. And you can see that there's been 215 commits. And in fact, in the last 2 months, he's updated the notes a little bit. What I want you to do is to fork this code. Okay, what does that mean? It means going up here and clicking on fork. What a fork is a copy of the repository into your GitHub account. It still has a few links back and forth. It lets you get updates if the course was ever to change. But I want you to fork it. Now, you probably only have one organization. I've already forked this because I did it before. I want you to fork it so that you have a copy of something called whatever your GitHub username is, Practical Python. That's important. Okay. So this is your copy, completely separate and independent from here. But you should have a repository with the name Practical Python. And this is going to contain everything we need to make it go. From here, what we're going to do is we're going to use this code thing and get a copy of the link. Now, if you haven't set up your SSH keys, you're welcome to use HTTPS. You probably should use SSH since passwords are deprecated. SSH, having a private key like we talked about last week, you go into settings in here to upload that private key. But the point is we need this magic string. This is the magic string that's going to let us connect our machine to GitHub. So I'm going to copy that string. Then I'm going to go into a terminal. Why can't I move the terminal? There we go. I'll just close this up. Well, sorry, we're going to go git clone, and we're going to hit return. And I'm not going to already return because Practical Python already exists because I already did that. I'm going to go into Practical Python, and there is the course. There is everything we're going to do for the next couple lectures. It's got the notes inside of it. It's got the solutions to all the exercises, should you need them. And it's got this directory called work. And inside the work directory is where you're going to put any code you write, any snippets, any examples. And then as we work through these exercises, what I want you to do is create a piece of content and then add it to here and then push it up to GitHub. And pushing it up to GitHub lets me see that you're working on this and moving through it. Okay, so for your own installation, you need a terminal that you have a prompt, and you almost always want to be in the work directory. And from here, we're gonna run and we're gonna launch Python, okay? And we're gonna do some stuff. Now, we'll start here. Okay, so let's just make sure this is working. So if you have a cloned repository and you're inside the work directory, we want to make sure that this works. Depending on your system, Python 3 is probably the name of your Python version. Okay, so if you say Python, possible, depending on your computer, if you type in Python -- version, Python 2 will come up. But the reality is Python 2 is now finally deprecated. No one should be doing anything with Python 2 anymore. It is end of life. So whether or not it's called Python 3 or Python on your computer, as long as it says 3.6 or bigger, totally fine for what we're doing. If you get command not found, then there's something you haven't set up properly on your machine. But I said if it's OS 10 or if it's Linux or if it's WSL, almost for sure you've got Python installed. And so I'm going to assume we got that all set up here. Okay, so here's how we're going to get going. We are going to type in the name of this interpreter to get it to run. Okay, so right away you're getting this triple prompt. This is what's called an interpreter or a program where you can type stuff in. And like the most useful thing that I have for Python in this version is it's just my calculator. Honestly, every month my wife and I do our finances. And one of the things she asks me to do is add up sort of all the money going out and add up all the money that's going in. She keeps her work on a notepad. And so she'll just read out a string of numbers to her. And so it'll be like, well, our gas bill was $90 and our electricity was 120 and insurance was 200 or 200. Oh, we have to buy some food. Okay, we have to pay for some mortgages. She says, well, what's the sum of that? And I say 2,160. And we then figure out how much we earn and we play things. I just use it as a calculator, right? Good, simple, interactive back and forth. Any Python command can be typed in this to environment and it immediately evaluates. So we call this a read, evaluate, print loop. Basically, some command like 2 + 2, return, it evaluates it, it prints it, and then it loops back to give you this line. And we can put in more complicated commands, right? So the one you might be aware of is the print command. It's print open rack and brackets, and we will do, of course, the world's most traditional first program. Print hello world, that's a statement in Python. It's going to read it in, it's going to evaluate it, it's going to print it, and then it'll ask us again, and it does something. Okay, that's the basic sequence of working within this textual environment. Now, if you want to get out of this, you got to know how to quit. Okay. Now, there is a hint here. It says type help for more information. But if you type in exit, it will tell you that exit actually isn't a command, but there is exit a function. So like print, it's a statement, and that's how you get out of Python. So how do you get into Python? Python, and then you do whatever you want to do. Okay. And then you get out of it. You have another option, which is a Control D. So it's very easy to get into Python and get out of Python. Okay, but there's another way of coding Python, which is to use scripts. Okay, with the idea of scripts is you open up a text editor, okay, hello.py, and then we can put the lines into this program, save it. Now I'm using VI, doesn't matter what you want to use. So now I have in this directory, hello.py, and the way that Python works is you say Python, or maybe for your system, Python 3, hello.py, and it runs the program. And that's how we're gonna work on Python, either interactively through this standardized interactive thing that's always in Python. There are more advanced versions, but this is the basic one. Or we're going to do it by writing scripts and getting things to work. That's going to be the basic back and forth. Now, because I want to show you the notes and the scripts and the terminal all at once, what I'm going to do is I'm going to open up VS Code. So in this directory, Practical Python, I'm going to go and actually open up a copy of VS Code, Visual Studio Code, and use that as my way of interacting with what's going on here, okay? So let me just zoom in on just this one window. Okay, so there's a couple things going on here. So this is Visual Studio Code. I'm actually connected to my Ubuntu environment. So any commands I'm typing in are actually running in Linux. This is a terminal. Hopefully that's visible to everybody. In this particular editor, I can look at a bunch of different files, and the notes are all in here. Now, the notes, let's just say the table of contents, this is what the file actually looks like. This is a format called Markdown. It's a styling way of representing text. It's sort of like HTML, but simpler. Links are just given by round brackets, stars make lists, double things are headings. This is one way of looking at the notes. What I've done is I've gone and installed an extension called Markdown All-in-One, because extensions are something that VS Code is based on. And what that lets me do is go to a file, and rather than just left-click on it, I can right-click on it and choose Open Preview, and now I get a rendered version of this notes. So I'm always going to just have a preview of those markdowns open so you can see what we're going to be working through. The other thing I'll do is I'll have the terminal always open so you can sort of see what lines I'm running my programs are. And then thirdly, any programs that I'm going to be working on, like this hello.py, I will stick here on the right-hand side so that you can see at any moment, contents, the notes, the program I'm currently working on, and a way of running it. So these three things sort of all work together. So now I can go Python hello.py, and I know that I'm running this program. Okay, so that's how I'm going to set this up. You set it up however you like. If you don't want to use VS Code and you want to have a terminal and an editor and a web browser and then me on Slack open, and that's how you arrange your screens, great. But that's the basic setup. So with that, I will just pause for a moment and ask the group, is everybody at this point where they can go to a terminal, they can type in Python or Python 3 and type something in, and you get stuff out? Anyone not with us? And I can see how you've all turned off your cameras, so I have no idea whether or not I'm with you or not, but that's fine. Okay, I'm going to continue because I haven't heard anybody say anything else. Okay, so here we go, Introduction to Python. My goal is to work through this thing today, this thing on Thursday, this thing next week, and then stop. There are other things you do for more advanced Python. And if you're already really competent in Python, go ahead and spend your time reading this other stuff. If this is all totally vanilla for you, but there's always a group of people who this is brand new to. So we're going to start with the introduction. I want to do these three things as a class, and we'll get to the other stuff maybe later, but it's not as important. Okay, introduction to Python. So here is the idea. So introduction to Python, as I said, Python is this very expressive scripting language. Perl, TCL, Ruby are similar to it. Loosely speaking, there are aspects of C programming that are sort of built in there. It dates from 1990, so it has been around for close to more than 30 years, I guess. It's a language, so it's invented by this guy Guido, who needed a version of it to do something. And here's his motivation. He wanted a language that was a bit higher level than C for this. He was working on Amoeba, an operating systems project. C was taking too long. Doing things in Bourne, which is Bash. Bourne shell is like Bash. Bash is the Bourne again shell. It was complicated. And so he wanted a programming language which was expressive and quick like shell, but more powerful than that, but not nearly as slow to develop for people as the C language. And so we came up with this thing called Python. Amoeba doesn't really exist anymore, but Python took off and went really, really fast. Okay, so again, Python, my expectation is Python. If that doesn't work for you, Python 3 might be what you need to do to make it go. That's going to, okay. So we're going to go. And the idea here is as we're going through the exercise, we're going to do them all. I'm going to do them. I want you to do them with me at the same time. You're playing around. So confirm that the calculator works. So if you wanted to solve a problem like Larry bought 75 shares of Google at this price, and they're now worth this price, you could figure it out. So we could do the same thing. We could say, you know what? Maybe you bought 400 Dogecoin when it was worth 0.001 pennies, and now it's worth 50 cents. How much money do you have? You have 200 bucks. I'm showing off because way long ago, I played around with Dogecoin, and I have like 400 shares when they were worth this, and now I have like 400 of this. I have like $200 in cryptocurrency. I'm not retiring anytime soon, but it was sort of a nice surprise when Elon Musk started boosting up Dogecoin. But you can do that kind of basic mathematics, and the mathematics follows the rules of order of operations, right? So whether or not it's division or multiplication, what's going to happen here is it's going to be in the same sequence that we would do 1 plus 6 divided by 6, right? Or divided by 12. I'll say that. 1 plus 6 divided by 12. Order of operations is going to kick in. So the 6 divided by 12 is going to work before the 1 plus. So if you really wanted to do it, you got to do it like math stuff and do proper order of operations. What is built into it? Plus, minus, divide, multiply. And here's a weird one, exponential. I don't know why they came up with this one and they didn't go with this, but that's what he went with for exponential. So if you want to know what 2 to the power of 16 is, that's how they do dev exponential. In the editor, there's this magic variable called underscore. I got the answer before, and it's useful for doing calculations, right? I may want to take this one and multiply by 2. That's just the previous answer and multiply by 2. Okay, so basic interaction, it works like a calculator. One of the features of Python, one of the reasons it's become popular, is it's got great internal documentation on it. So for example, let's say I needed to use the ABS function. I want to figure out what it does. Well, what's ABS? ABS of 2 is 2. Well, what is this thing? There is a function called help that gives you documentation on any of the functions. So ABS, right in there, it says it takes an argument. That's it, just one argument. What does it do? It returns the absolute value of the argument. Now, if you might be looking at this thing going, well, I type that in, how do I get out? This is a pager in the terminal. Q to quit in terms of it. So there is a built-in help functionality. So if there's something you want to learn about, you type in help, and then you have the information. You have whatever you want for that command. So the print command, here's its full documentation. It's got the ability to separate different enders, Q to exit. There are other ways of interacting with Python, which give you other tools for doing this, but in this native one, there is a basic help command, and it's for any function, okay? It doesn't work for if, while, those are not functions within it, they're commands. So if you try and say help of 4, that won't work because it's trying to evaluate that as a piece of code. However, Okay, so right away, you're getting information on how the for loop works, and it's all built in there. There is pretty great documentation on Python. Go to docs.python and take a look at it. And you can see all of the functionality that's built into the language and its standard library, and there is a lot that's in there. So as you're learning this language, especially if it's new to you, get into the habit of just browsing the documentation. Okay, what we're going to do here is we are going to really try to learn the language by doing it. And so what that means is when you're doing this, try and type them out by hand, okay? Yes, you totally could just copy and paste it, but try and avoid that. So if you were to copy and paste, okay, as in I highlight this, Control C, Control V, that would work. If I copy something which is only a partial line, it'll give me the triple dot saying, that statement's not done yet. You need to give me more before I'm able to understand it, okay? So you can copy things in pieces. You can copy things with enters, and then the terminal will automatically fit that in. If you're doing something which is multiple lines, that will also work. But here is something about Python. When you're copying it, it's not just this by itself. If you just say for this all by itself and then hit return, oh, well, I must have mistaken there somewhere. Why did it work once and not before? Oh, because I didn't have it right. When you're copying and pasting, this space is actually an important bit of what copying and pasting. We'll learn that Python indentation is actually syntactically relevant. So if you do decide to copy and paste, make sure you copy and paste the whole block, not just pieces. But we're going to type things out by hand. Okay, so let's do something slightly more interesting with Python. Okay, so here's my terminal. There are a whole bunch, many libraries which are guaranteed to be there if you are using the default installation of Python. For example, there is a library called URL lib. And the way you bring in a library is you use the import statement. So import URL lib.request. That is now giving Python access to a function called URL open. And what you can do is you can run that function, URL lib request URL open, and that does the effect of going to a web page and giving me whatever the output is from that web page. Now, this is a long string. This is an example where I think copying and pasting makes a lot of sense. So I'm going to copy that string. This is, URL rec request.url open. Okay, here's what this does. It gives me something called a response object. Okay, well, what's a response object? A response object is something that comes back from HTTP, from web clients. We need to take that response and do something to it. And you can do that with another element. Actually, what ends up turning back from this thing is a, so I'm just going to take the output from this and throw it into a variable. I think it's body. No, H, I don't know what it is. Let's just try it. There is another function that will take it and parse the information from that. Just for speed, I'll copy and paste that. If I then run a function on that, what I've done is I have taken that data and parsed it into pieces. Oh, doc. There we go. It's now an element tree. Element tree comes from a language called XML. And I can now go through that file looking for all of the elements of type PT. And getting out the times of when this bus in Chicago is going to next come. So on stop 14792, route 22, and I believe this is the Chicago bus tracker, what we're doing is we're letting Python communicate with the web and then take the output from that and parse it so you're getting individual points. So the details of how this works isn't important. It's just that within 2 lines, what Python has enabled us to do is download a web page, parse an XML document, and extract some useful information about it, right? If we waited like 6 or 7 minutes, these numbers are going to change because this is a live website. So if I go along and I run that command again, oh, it hasn't been a full minute. Eventually we'll say 3 and 7 and 19 as these things go down. Okay. A few things going on with when we run that. The first thing is, whenever I do a for loop in Python, and the way that for loops work, it's for and then a variable, in, and then a sequence of things that we're going to iterate through. After that, there needs to be an indentation. And the standard is 4 spaces, which in many editors gets mapped to a tab character, but I would suggest that you use 4 spaces to indent this. These indents are part of the language. They're not just for making it look pretty. It's how you separate out a block of code. The second thing I'll draw your attention to is there is a way of importing libraries, Node.js, R, Julia, have this idea of modules or packages. C has header files and similar things like this. This is a mechanism whereby Python brings information, and there's 2 ways it works. One is you either import a module, and then the entire module name gets added as a namespace, and all of its functions are URL request dot something. Or what you can do is you can take a module and pull out from that namespace an individual function. So these are the 2 methods where functionality is imported into Python. And the details of what they are is important. What I'm drawing your attention to is import something, or from something, import something. Those are the basic ways of getting additional functionality into Python. If for whatever reason this import URL request didn't work, you are using Python 2. Don't use Python 2. Just avoid it. It is now deprecated, end of life. You should not be using Python 2. It is possible that you needed to set an environment variable to get around a proxy server. There is the way within Python to set environment variables. How do you do that? Well, the OS module gives us access to a whole bunch of things about our operating system, namely all our environment variables. There are all my environment variables, okay? And if I wanted to set one of those environment variables, we talked about the path the other day. That's my path. That's my prompt. Oh, there's no prompt in that environment variable. Interesting. You can set an environment variable for the proxy if you wanted to, or if you needed to, depending on what you're doing. But don't worry about it. This is just an introduction. We're not doing anything with XML at this moment. Okay, let's take a look at something practical here. I've explained that when we run Python, we're always running inside of an interpreter. So you can think about an interpreter as these triple lines. This is a read, evaluate, print, loop interpreter. When we run a program, it's also interpreting these files line by line as if we had typed it out all the way through, okay? This interactive way is a really great way of testing. You can think of like a playground. You can just see, what does this do? What does this command do? And whether or not it's print hello or multiplication or a loop, it's a way of just easy trying out something, right? Make sure that you know how to do it, right? You might be familiar with an integrated development environment or some other way. Make sure you have the ability to get to a prompt that looks like this and type these things in, and it works. We talked about the underscore. This underscore thing is an interactive trick only. You never use the underscore in an actual program. So hopefully you got that all working. There are more advanced ways of interacting with it. There's an interpreter called IPython, which gives you a whole bunch of new functionality. We'll get to that later, but right now let's just keep it the vanilla stuff. The other way is to create a program by putting it into a file, okay? So what I've done right here is I've created a file. Now, remember, to create a file, you can do one of a few things. You can either take a file, touch it. As soon as the file has been touched, then it's going to exist, and you can open it up in an editor. You can open it up in a text-based editor if you want, and if you wanted to make some change to it. Well, I don't even know how to use Nano. I use VI. You are welcome to edit the file. Okay. And then depending on your editor, that might get changed or not. You can do everything in the command line if that's how you want to work, or you could edit it up here in the terminal. Sorry, in your editor. Remember to save if you don't have auto saving turned on, and then you can run your program. Okay. Python programs have the extension .py by convention. They don't have to have a .py, but we always do put a py if it's a Python program. These are comments. So anytime you have a program, if you have a hash at the beginning, those will be py. Those will be ignored by the Python interpreter. Okay, so how do you run these programs? Python space hello. That's how we're going to run all these scripts. I want you to be using a Linux OS X type environment, but you can do this in Python. Python has more users in the Windows space than they do anywhere else. Okay, let's be a little bit more aggressive. Solve a problem. So let's say that here's the scenario. One morning, go out and you place a dollar bill on the sidewalk beside this very tall building called the Sears Tower in Chicago. And every day afterwards, you go out and you double the number of bills. How long does it take the stack of bills to exceed the height of the tower? Okay, so we're going to write a program that's basically going to have a count, which is how many bills you got and how tall a tower would be that number of bills, and grow it bigger and bigger and bigger until it exceeds the size of the Sears Tower. Okay, so here is a solution to this problem. Okay, so what we're going to do is I'm going to go through it and I'm going to type it out so that you can we can just talk about what's going on and talk about things about Python. At any time, turn on your mic and just be like, oh, I have something I wanted to ask about, and we'll get there. Okay, so first thing, I need a file. There is no Sears.py in this directory. Okay, I want everything done inside that work directory, please. We're going to create a file. Right? So what I'm going to do is I'm just going to go Control, New File, and I'm going to save this thing as Sears.py. Now I have a file I can edit. Right? I need, if I'm going to figure out how tall a stack of dollar bills is, I'm going to need some information about how thick a dollar bill is. So I go to Wikipedia maybe, and I look it up. Well, I'm going to put this into a variable called bill_thickness. Well, it turns out that these things are about a 0.11 millimeters. I did not know a dollar bill was that thin, but I'm going to go with it. That's how many millimeters. Convert from millimeters to meters. I'll put a comment that I'm doing it in meters and then a little note to myself of what this was. And you can see that I've got a line of code, which is defining a variable, doing a calculation on the fly, and doing an inline comment to explain what's going on. First thing about Python, there is no variable declarations. You do not need to do something like, okay, these kind of commands, int, var, floats, that's not needed. Python is able to figure out that if it's never seen the variable before, you probably want it to do something, so it'll start working. This is both a joy because you don't need to type it out, but an annoyance because you can imagine writing a program. Oh, no, not dot, annotations. You're writing a program. Okay, and then later on, you type in something. Okay, imagine just for the sake of argument that this was your program. This is a completely valid Python program. Python will not complain that you've got a variable called thickness and a variable called thick without the K-ness. This can be the source of many a bug. And this one, you're like, oh, I would notice that. I would never make that mistake. Here's one that gets people all the time. Depending on your font, there's no easy way of telling the difference between bill thickness 0 and bill thickness O. Be careful. Python will not have a problem with this. Now, what Python does do well is you can't use a variable before you use it, right? So we'll make the same mistake. Oh, well, it's my editor is like forcing me not to make the mistake. I'm using an editor that does some on-the-fly syntax checking, and it's saying, oh, hey, buddy, I've never seen bill thickness before. This is my editor doing some work for me. If I was doing this in a textual editor, there's no such feedback, right? So you need to do it correctly all the way through. So be aware that variables are defined on the fly. The other thing that's going on, so I'll fix this so there's no errors, is Python doesn't have it has a concept of variable type, but all of these labels are not actually typed. It's an untyped or dynamically typed system. And so what that means is bill thickness is a floating point number, Sears height is an integer, but there's no way of telling it ahead of time which kind of variable it is. Python uses something called duck typing. What is duck typing? If something acts like a floating point and it looks like a floating point, then it is a floating point. If it acts like an integer and it looks like an integer, then it is an integer. It's called duck typing because if it looks like a duck, it walks like a duck, it quacks like a duck, it's probably a duck. And that can be really useful until you get into some weird edge cases where you really care for things. If you like typed languages, like you like TypeScript and you don't like JavaScript, there are ways of getting some type annotations into Python, but as a part of the language is inherently dynamically typed. You don't get to control the type explicitly. If you don't know what a type is, don't worry about it. It's not a thing. If you're a computer science person, you know what a type is. It's just a dynamically typed line. Okay, so there's the first thing. We've defined some variables. Let's continue on. What I want to do is have a few more variables that talk about the number of bills that I might have, and then what day it happens to be. Because in this scenario, every day I'm going to put a dollar bill down and look at how tall it is. There are a number of looping constructs in Python. There's a for loop. There's also a while loop. While, what it does is while a condition is not met, okay? So while something is either true or false, do the stuff beneath it. So what we're going to do is say while num bills times bill thickness is less than the height of the Sears Tower, right? Do whatever is underneath this. Because of order of operations, the times is going to get executed before the less than. At the end of these statements, we put a colon that indicates that below here is going to be a block. Now I've set up my editor so that it will automatically indent for me. It's 4 spaces. You can, but please just use 4 spaces. It's going to make your life easier all the way through. Anything inside this indentation is going to occur every time this inequality is verified. So what I'm going to do is every day, I'm going to come along and print the current day, the number of bills I put in front of the tower, and then how tall the tower is. Number of bills times bill thickness, okay? And every day, I'm going to take the number of days and I'm going to add 1 to it. And I'm going to take the number of bills that I have in there, and I'm going to take the number of bills and multiply it by 2. Okay, so what this is going to do is all of the code inside this indentation represents a block. Other programming languages you might have used may use braces to represent that. Python uses white space, that is returns and indents, as syntactical elements. So if the code is formatted correctly, it runs correctly. You can't do any weird things like put all this stuff onto one line. There's no semicolons, so you can use a semicolon, but we typically don't. End of line, returns, mark new statements. You indent blocks, and the blocks are always indented with 1, 2, 3, 4 dots. There are ways around that, but that's what's going to happen. And as we run this program, numBills starts at 1, and every time through this loop, the number of bills is going to double, and this conditional is going to be re-examined, and it's going to work. At the end of the day, we may want our program to print something out to tell us what it did. Okay, so I may want to print out the number of days, and print has a list of things. You can just put anything you want inside of a print. You can put strings, you can put variable names, you can put out number of bills. So we can have, say, 2 variables. And actually, the way that variables work is anytime you have a variable, you can replace it with an expression. So what I can do is I can have print final height, and then I can put in an expression. Oh, that's not my expression. Highlighting that, yank. Number of bills. Okay. No, not. No, that's fine. I won't auto format it. Okay. Right. So there's my program. So here's, you can see the program. What does the program do? It initializes something, it's got the body of the program, and it does something else. How do I go about running this program? Python sears.py. Okay, so here is the program. What we get is, and I'll sort of show it up here. On the first day, like the first day of Christmas, on the first day of the program, I have 1 bill, and it has a stack of 1/10 of a millimeter. On the second day, 2/10 of a millimeter. On the 5th day, I only have 16 bills, still very, very thin. But you can see the nature of this exponential growth. Every day, I double the number of bills. And so by the time I get to day number 23, I am at a height taller than the Sears building, and it has taken me whatever that is, $4.1 million to get to the top of the Sears building. I have no idea how they made it tall, that tall, but that's the idea. So Python programs, no introduction, no headers. You can just start using variables right away. You can have expressions. The text is basically, you use these block statements for while loops and functions and things like that. How do you run the program? You say Python or Python 3 space the name of the file. That's the idea. It's all broken up into statements. Every one of these things is a statement, a variable assignment statement, a print statement, a while statement. Some statements introduce blocks. Variable names. You can use a variable name. You are allowed to use letters, uppercase and lowercase, though it's case sensitive. So capital letters are different than lower cases. You are allowed to use underscores. Numbers can be part of it. Letters, you'd probably be annoying to someone later on, but you know, it's allowed. You can't use spaces, you can't use dots, colons, tabs, returns, brackets, round or square, or curly, question marks, basically punctuation. Stay away from punctuation. Everything else is just fine. As I said, types don't need to be declared. They're figured out on the fly. So if you say height equals 422, 422.0, or height equals really tall, Python will infer the type by looking at it. And there's nothing special about this word that keeps it from one a type or another. So if I open up Python and I say height equals 222, right? Then the type of height is an integer. If I say height is equal to 222.0, the type of height is a float. If I say height equals not that tall, and I say type of height, then the type is determined to be a string. Height doesn't have a type. It's just an identifier that is pointing to one of these three things, and the type is inferred. As I said, Python is case sensitive. So these are three different variables. Language parameters, what's being highlighted here in purple, are always lowercase. And I just talked about looping. Looping, there's a while, there's a for. While this condition is true, colon, bunch of statements, do it again and again and again. And I said we always indent for everything we're doing. Okay, conditional. Okay, so we talked about variables, we talked about while. The next thing you need while loops, and there's one fundamental thing you need in a program, which is a conditional, okay? So what I'm going to do here is I'm going to add some additional lines, and I'm going to say if num bills times bill thickness is greater than money I have, you have enough money to do this strange thing, else print, go find more money first before crying. Okay, so there is an example of a line. I'm just gonna yank 5 yank, D5D. Okay, so it's telling me I don't have this variable money I have. I'll put that up front. Money I have. Let's say I have $1 million. 1, 2, 3, 1, 2, 3. Okay. Then if I run my program, right, it's figuring out that I do not have more. I only have $1 million. It's not enough. So it's evaluating this thing. That's false. It skips this block. It goes to the else, and it does this instead. Like with whiles, you're separating out the code based on colons and indentation. If you want to have multiple lines, go ahead. So if I was not a millionaire, but a billionaire, not a millionaire, a billionaire, right? I'm not a billionaire. But if I was, well, money I have $1 billion. Ooh.
I think the condition is wrong, Professor.
You think the condition is wrong?
Yeah, shouldn't it be less than?
Well, if the number of bills times the bill thickness is, oh, no. Good point. Right? 1, because if I have 1 bill, I have $1. That's a mistake, right? I was thinking about the final height. Okay, now we can test it. Now we can run a program. We can say Python Sears. Isn't the number of bills this? If the number of bills is greater than, well, how much is money I have? You only have money I have. What am I doing wrong? And you probably
Professor,
all see it.
Hello, Professor.
Yeah.
Number of bills into 1 greater than money I have. So if it is true, then we will print you have enough money to do the strange thing, right?
Oh,
if the condition is true,
sorry. I gotcha.
yeah,
I gotcha. D word space. You want that, right? There, I have enough money. And if I didn't have enough money, haha, good. Okay, thank you. That's a good demonstration. Got to get these equalities working out. There are ways of debugging these things, but that's the basic idea. We can sort of see what these programs actually have to do. Okay, so that's just an if statement. No problem there. If you did need a whole chain of things, you can have ifs, else ifs, and elses. That's allowed. And these printing things can be any sequence of guys you want to print out. Just a sequence of things. There's ways of formatting. We'll talk about formatting later on. Okay, there is a way of doing user input. Okay, so just like the read-p in Bash, there is a function called input, which will ask a question from the screen. Okay, so if I type in Python and I say name equals who are you? Okay, it will ask me a question and wait for me to type in my name, and then name will be in there. So this does exist. While it exists, you never want to use it. This should not be something that is in your programs at all. This is useful for maybe some debugging, but it's not widely used in real programs. What is widely used in real programs, and I think this is a good time to talk about it, is arguments. Do you remember how we were doing shell scripting? And what we wanted to do is something like this, the money I have, right? Maybe that's a variable. So I can do pi share and I have $100. Say I want to run a program like this. Well, this doesn't work. This isn't the right way of doing it. The way that we get arguments in Python is there is a module called sys, and there is a structure called argv. It's called variable arguments. And what you're doing is it's taking the first argument on the list. Okay, so if I type in, I'm just going to demo this for a second, print money I have, money I have. Okay, so if we just run that program, okay, whoop, I went too far here. Money I have 100. Okay, so that's what read in, but it's just reading in that characters, those characters of 100. If I said money I have apple, it'll be totally fine with that. What we want to do is we want to convert that string to probably a floating point so we actually can do a comparison on it. So how do I bring in variables? I use sys, and then I can run my program. Apple isn't a valid number. 100 is. I only have $100. Go find more money before trying. No, don't. So on and so forth. Finally, there is something about this block nature, which gets a little bit weird. Sometimes what you want to do is you want to have a block that does nothing, right? So if 2 is bigger than 5, right? I'm not sure what I want right there. Else, right? You may want to have some line here. The rules of Python is after one of these colons, you must have an indented statement. Okay, so there is the need in the language to have a nothing statement, a statement that doesn't do anything. And that statement is called pass. So you always can have a file that just does nothing. And in fact, that gives you the beginning of your simplest possible Python program. So If you wanted a really simple Python program, that is a valid Python program. Okay, because if I just say Python simple, it doesn't do anything. Okay, pass is a command built into the language, which just does nothing. It's an empty statement, but it's needed because of this syntactical nature that every block needs to have some code inside of it. Okay, here's where we're at now. We're going to do some coding, okay? And the coding we're going to do is an exercise, right? So I want you to write a program that figures out how a ball bounces. So here's the setup. So it's some really basic physics. We're going to say you got a rubber ball drop from a height of 100 meters. And every time the ball hits the ground, it bounces up to 3/5 of the height it fell. And what I want you to do is write a program that makes it bounce. Okay, what's it going to do as output? It's going to produce that all the way through. So here's what we're going to do. I'm going to give you a bit of time, but also a bit of a break. So take a break now, come back to it, or do this and then take a break. Write a program bounce which solves this problem. Okay, so what are you going to need to use? You're going to have a loop. You're going to have some variables. And what I want you to do is produce this output. Okay, write a program that makes that appear on the screen. Where should you put it? There is already in the work directory a file, a directory called bounce. So I want you to edit that file. And whether or not you use nano, or whether or not, as many of you said inside of your response to question 1, you told me you could go right from the command line and edit a file, code space bounce, you get a prompt. And so there you go. You work on that. You try and write a program that does this question, and then we'll take it up as a group. Let's see here. 10 minutes to do this, 10 minutes for a break. So look at this at what's 20 minutes from now? That would be 1:35:05, 3:05. Is 3:05 the right time zone?
That's correct. Yeah, for St. John's, Newfoundland.
Okay, good. No problem. So 20 minutes. Says take a stretching break, but try some Python program. And again, if this is like I've been Python programming for years, I got this. We will get to some stuff that's new, but we're just gonna keep everything along. Just whip through these exercises, but fill them out. Give me something. Write this code. Figure out how to do formatting so it looks you can round it, right? But if it's brute new to you, try and figure it out, and I will see you in about 20 minutes. Cheers, all. Okay, I guess we should get back to it. Seeing where everyone else is. I'm assuming that I'm unmuted. I can't hear or see anyone else, so I hope you're there. Okay, so I had left you with this exercise, just sort of make sure that it was all working, and you were supposed to write a program to make this thing do its stuff, right? So it's a basic loop. There are lots of ways of running this program. So let's just pick a volunteer. Let's just see someone's code and go through this. So I'll just stop this share for a moment. Anyone willing to show us your solution? What's your bounce.py code look like?
Yes, Professor, I can do that.
Great, Arnab, you done. Show us the screen.
So can you see my screen?
Yes, I can. Okay, so that's the solution. What's the code look like?
Yeah, I can show you the code.
Nice.
So here is my code.
Okay, so bounce is 10. Okay, so you explain to us what's going on in this code. What does it do? How does it work?
You know, the initial height is 100, and
Yep.
I have to print what is the height after 10 for each bounce, each first of 10 bounces, first 10 bounces. So
Yep.
here is the bounces is set to 10. So the
Yep.
loop will continue until the bounces become 0.
Yep.
So until the bounces become 0, I will just calculate the height. I will multiply it by 3 by 5 each time. Then I will
Yep.
just print the number of the iteration and the height.
Yep. Mm-hmm.
And I will just reduce the bounces by 1 and increase the number of iteration by 1.
Okay, sounds great. Okay, and then you'll know that when you get to the bounces equal to 0, it'll stop. Okay, so a couple comments on your code in terms of being good Pythonic code. So first thing, your while condition. Generally, testing for equality with a specific number or inequality with a specific number can be dangerous. Okay, now here they're integers. It's going to be not equal to 0. It'll probably be fine. But generally, I would use an inequality like greater than or less than. And it has to do with how floating point numbers can be resolved perfectly within a computer. Usually what we would want is an inequality. Furthermore, however, the bounce is greater than 0, because that makes it really clear what's going on. Okay, second thing, you use this syntax plus equals and minus equals. For those in the class, they wouldn't be greater than equal to, it'd be greater than. Right?
So, yeah.
It wouldn't be greater than equal to, it'd just be greater than.
Sorry, can you repeat?
Your while statement. While bounces is greater than 0.
Yeah.
Because you want to stop when it becomes 0, right?
Yeah.
So it's a strict inequality.
Yeah.
So get rid of the equal. Get rid of the equal sign right there.
Okay.
Awesome. Great. Okay. I have no problem with you using minus equals and plus equals. My question was, what does that mean?
It's just the minus equal means this one. So the bounces will be reduced by 1 and it will be assigned to the bounces again.
Gotcha. So there are a bunch of operations, minus equals, plus equals, that take a value and do an update to them, right? It takes the value, does the mathematical operation, and redo it. Totally fine to use that. But if you're going to use that, you could actually use that for equals height times 3/5 as well.
Yeah.
Right? So
Yeah.
you could say height star equals 3/5. Right? And I guess my to be Pythonic about it is I would like use the same structure. However you want to code it up, just do the same thing for all 3 lines. It's easier to read, less cognitive load.
Yeah.
Okay, so that's great. That will definitely work. Okay, now your indents are a bit weird here. I agree you have to indent the while. You know what? Stop right here. Save this and run this program because I want to show you an error.
Okay.
So just save it. So escape colon WQ. Yeah. Right. And run that program. Do you understand what the error is?
And between before 5.
That's right. Okay, so let's fix that. So indentations are meaningful in Python, and so you can't just indent code wherever you like. You've got to be consistent.
Yeah.
Okay, so as written, that's file. Now that's invalid Python code, but you're fixing it. Okay. Get it there. Okay, test it again. Got a mistake.
Okay, I got another
Right.
here.
Another area, and this is okay. So this actually leads into exactly what I want to get into, which is talking about debugging. Okay, so whenever in Python you get an error, it's telling you what the error is. It's going to say, I don't know what this word means, PRNT, or there's an error in the in the program. Imagine this program was very long. It wasn't just 8 lines long, but it was 800 lines long. Go back and make that mistake, PRNT. Just like put the error in and run the program. Or we can see where the error is. The error is at the line at the bottom. You see it says name error, name print is not defined. That's the error. But what it's giving you is information about where to find the error. It's saying it's on line 6. Do you see that?
Yeah.
Okay. And this is not just for you. It's for everybody. You should be able to, in a text editor, go to line 6. So you're a VI user. So let's open up Pounce. How do you immediately go to line 6? Do you know how to do that?
No.
Okay. So VI has this shortcut where you use a colon and then a number. So if you are colon 6, yeah, that's it. It will always jump to line 6. So these error message is saying the error is on line 6. You want to be able to go to line 6 right away. So that's really useful. The other thing is I see that you've set up VI so that you've got the ruler in the bottom right-hand corner. So you can see line 6. You know, it says 6,8.
Yeah.
Yeah, so that's telling you something. And the final thing, you can use line numbers in VI, right? So colon SET space line node.
Hello, Professor.
I'm muted. I'm sorry. Number, NUMBER.
Like this?
Yeah, like that. Hit return. Yay! So these are useful tricks as you're using VI as your editor of choice, right? To be able to debug things. And it doesn't matter what editor you're using. Line numbers, syntax highlighting, these are all useful things. Okay, so I'm totally fine with that. You got it. Does anyone else have a question about this level of syntax? Are you comfortable with Python and doing a program like this, or is there anything we should talk about? Okay, hearing none, let's just continue on. So that's a great solution. Okay, so as you're doing these exercises, I remember I wanted everything in the work directory. The reason I wanted it in the work directory is so that you can show me what you've done. Now, we're inside the work directory. All of your files you're working on should be inside of work. If I say git diff bounce, it should have whatever code you added, right? So if your solution was, now there's other ways of doing it, but sure, wow, bounces is less than 10, height equals, oh, let's use that idea, 3/5, bounces equals 1, bounces equals, well, should be 0, the height equals 100, print what? Bounce height, right? So whatever your program happens to be, and I'm not sure if I got that right or not. Bounce is not defined. Bounce is. Yeah, okay, so something like that. So you have some code, wherever your solution is. You can see that because this is inside of a repository, if you do a git diff bounce, you can see your solution. So that means you can do a git add bounce, and you can do a git commit solution to exercise 1.5. So what I'd like you to do to sort of confirm that you did this is when you've got your solution to bounce.py, add it, commit it, push it. And that shows me, I can go back and quickly glance at this stuff and be like, yeah, you did this exercise. Now, it's really not about getting the answer correct. It's working through it and trying to learn it. At any time, if you're doing one of these exercises and you're like, well, I want to see the answer. I don't know what to do. Full disclosure, all the answers are here. So you see solutions 1.5, bounce 0.5, there is the solution. Okay. My solution and his solution are similar, not exactly the same, but pretty close. There's the official solution. Don't copy and paste the solution. Work through it on your own to sort of understand the idea, but it is there if you ever need it. Okay, so I want you to be, as a habit, once you complete an exercise, right, go ahead, add that file and commit it in there, just so I see some progress being done in this account. Okay, debugging. Okay, let's talk about debugging for a second. Okay, so I'm going to take this program. D from 3D. No, D from 3D. Okay, so here is a program that it's telling me to type in. It says, take this program, copy and paste it into here. Okay, copy and paste it into a program called Sears.py. Okay, I did that. Then run that program. Okay, days is not defined. Okay, so this is what I was just talking about before. This is what's called a traceback. Okay, the error is always the very last thing in it, and there's a whole bunch of different kinds of errors. Internally, it's throwing an exception. And that error is appearing here. It's saying, I don't know what the word days is. It's telling us that in this file, Sears.py, on line 10 is this error. So if I go to this program and I go :10, if I'm using VI, right, it'll go to it right away. Now, my editor knows a little bit of Python, so it's actually highlighting this and telling me what's going on. VS Code works really, really well with Python. So does PyCharm. So does a whole bunch of other editors, Spider. These are great tools to help you, but you should be able to read what this bug is. And the bug is, I don't know what the word days is. And what's the problem? I have a day and I have a days. And so the solution, of course, is to get rid of that day. And then you fix the problem and test it again. Okay, as a matter of practice, okay, and if you've done a lot of programming, you already know this, but this is something we should talk about. Reading error message is an important part of a Python code. So when a program doesn't work, okay, it is useless to say to someone like me, my program doesn't work. At absolute minimum, okay, you want to show somebody the output and the full error message, the whole traceback. Now, this file could be really long, but you want to show everything in there because the error is built into it. You want to show this whole thing, this whole block of text, because it tells you where the line is, what the error is, and then this is what you need to read. Where's the line, error? What file? What line? What's the error? Then what you do is you try and fix the error. You recognize that days should be days, and then you do what's called testing. You run the program again and confirm the program isn't there anymore. Okay, so this is the normal workflow of the coding. You've got something, you make a change, and then once you've made the change, you say fixed a bug with the name of day, and then you push it, right? So while you're coding, you will not just have one commit per project. You will not have one commit per day. It is entirely possible that you will have dozens of commits as you are doing your programming. In fact, you can commit every time you've accomplished some task, some part of what you're working on. Now, if you're using an editor like VS Code, there are ways of adding that in so that you can do it very, very quickly, right? I could let's put today's date in, 21/05/17. Okay, so I save this, and Git is able to. Oh, let me just refresh that. Git is able to see, or this tool, this extension of the VI is able to see that this is this problem. And so what I can do is I can stage that. And then once I've staged it, I can commit it. Of course, you always have to commit, add date, and done, right? So the commits can be very rapid, very, very fast if you're using an environment like VS Code or you're doing the command line. But get in the habit of doing commits often. You always can undo the commit. Remember, we talked about git, log, seers. You can have this sequence. And if you make a mistake, you can always go back to a previous version of it, but only if you actually remember to commit it. So get in the habit of committing early and committing often. Lots of commits. Don't worry about how many commits you make. Do them as many as you can. It's helpful for debugging. Practicing debugging skills is useful. Now, there are more advanced debugging skills, okay? There are the ability to debug a program. We've just been talking about using tracebacks, the error message as a way of doing it. There are a number of tools that help us debug programs. And so I'm just going to highlight one of them, which is VS Code, which is one of the things I'm recommending. See these little dots? If I put a dot here and I use this little triangle, or rather, I won't do this. I'll say start debugging. What'll happen is I'll have the ability to interactively step through this program and watch the program proceed. These symbols on the right-hand side say where I currently am. This symbol is saying step over to the next line. And you see that when bill thickness is executed, then I'm seeing the value of bill thickness right here in this variable. Sears height doesn't exist yet because we haven't yet executed this line. We can step over this. I can step over this, and I can step over this. And then I can actually go into and look at how this program is progressing. And at any time, I can evaluate these things. Editors, any editor that is decent has a bunch of functionality. Not only can I hover over a variable like numBills and get its instantaneous value, okay? I'm pretty sure that if I hover over an expression, it will, no, we'll do that. Let's do this. I can open up what's called the debug console, and you see this line? This is Python, okay? But it's Python running in the middle of this program. So if I wanted to know what numBills times bill thickness was, I could run that while I'm concurrently debugging the program. If I wanted to look at Sears height, I could just ask her. I could take this entire line of code and be like, what's that going to give me? Whoa, don't do that. Control C. There we go, Control V. Oh, there's an error because of the $sign. That's going to be a true. So I know that if I step forward on this, I can decide what this is going to evaluate to before executing it to try and debug what's going on. And if I wanted to just jump to a line down here, I could put a breakpoint and then continue the program along. And the program will do this loop again and again and again until it hits this next thing called a breakpoint. And then I can just finish off running the program. Having debugging tools like this can be helpful. It comes out of the box in VS Code. All the different editors will have something like that. As you encounter bugs, try and play with ways of debugging your code to try and to find the errors. But we're going to focus primarily on just inspecting the code to see if we can see where the mistake is. Okay, anyways, let's talk about some data types. Okay, so Python has a number of data types built in. There isn't a number data type, but it actually knows about Booleans, integers, floats, and complex. There's no such thing as a float or a double. Bools are a native data type in Python, and they're characterized by the symbols true and false with a capital T and a capital F. If you were to try and run Python and type in lowercase false, it's going to say name false not defined. So if you're a JavaScript person, I'm sorry, that's just not what they went with. They went with capital F for false. You can think of a true and a false as being equivalent to a 1 and a 0. So 4 plus 1 is 5. 0 is effectively equivalent to 1. But that would be weird, so don't do that. Integers are the next data type. Integers have the wonderful value that they can be arbitrarily sized, okay? So you're not limited in Python to integers in a certain range. If you're familiar with languages like C or Fortran, you'll know that there's a maximum integer size. Python understands the idea of arbitrarily long integers. So if you really wanted to multiply 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8, go on for a long, long time, it'll do it. It understands that concept natively. It also has support for hexadecimal, octal, and binary should you ever need that. Integers have the ability to do a bunch of mathematical operations on them. We've already talked about add, subtract, and multiply. Divide is a bit weird because if I take an integer and I divide another integer, the answer to that is mathematically not an integer. It's 3.5. So Python, and this was a change in Python 3 versus Python 2, they decided so many people were taking 7 divided by 2 and expecting to get 3.5, they made it 3.5. Well, why is that weird? If I take 4 divided by 2, what do you think the answer is to 4 divided by 2? And I'm hoping what you're saying is 2, and at which point I'd say you're only partly right, because 4 divided by 2 is not 2, it's 2.0. And at this point, you may be going, what's the difference between 2 and 2.0? Well, 2's are integers. 2.0 are floats. And they're subtly different in how they're stored numerically. Now, if you do actually want an integer and then you divide it to get another integer, there's called a floor divide, okay? And for integers, it does the thing you expect. For odd numbers, it produces an integer. Back in the day, division in Python used to be this kind of division, and they got rid of that. There's also modulos and powers, bit shifting, if you need to do any of this kind of stuff, and absolute value. So these are built into the base language, and these are the operations we can do on integers. They have no limitation. You can make them as big as you like. Floating points are a different beast. A floating point number has a maximum value and a minimum value. It has a representation in memory of a certain number of bits. You all know a lot about computers. You've heard about bits and bytes. You know there's 8 bits to the byte. There are 4 bytes to the float, I think is what it would be. Nope, 8. There are 8. It's double precision. There are 8 bytes to every float. What that means is you're able to store a number with 17 digits of precision, and your exponent can be as big as 10 to the power 308 or as small as 10 to the power minus 308. What that means is you're limited in your floating point numbers. Not all floating point numbers exist.
Professor, you are muted. Hello, Professor, you are muted.
You guys still there? How about that?
Yeah, it's working now.
How about that?
Yeah, we can hear you.
Okay, so I was using a phone and my phone just decided to cut out, even though it's plugged in. Maybe you can't have a 2-hour phone call. I wonder if you're not allowed to have a 2-hour phone call. We'll try and use this and we'll continue. And if I get cut off, we'll figure it out. Thanks very much. I'm not always looking at that chat, but just speak up and talk. Because like I don't have feedback. I can't see any of you guys because no one else has their camera on. I don't know if I'm working or not. It's fine. Okay, we'll continue. Okay, so this is a bit weird. Let's define a number equal to 2.1 and 4.2. Okay. And now here's a question. Is the value A the same, has equality with 6.3? And the answer is no. Now this is bizarre. This is weird. If I say A equals 2 plus 4, and I say A is equivalent to 6, it's going to be true. There's no problem there. But if I have equal 2.1 and 4.2, 4.1 plus 4.2 is not 6.3. More specifically, it's not 6.300000000 because of how floating points are represented in the CPU. 6.3 is not resolved, or rather 2.1 plus 4.2 turns out to be 6.300000001. So there's a reality about floating points, which only certain floating points can be represented. And if you're familiar with this kind of stuff, great. If not, take a look at IEEE 754. It says what all the rules are about this. It has nothing to do with Python. What it means is equality is not something you want to use with floating point numbers. If you want to figure out whether or not 2 floating points numbers are the same, usually what you would do is you would say, okay, I want to figure out whether or not the difference between a number and a floating point number is small, where small is whatever you want to say. I guess I should do the math right. Wherever the number is as small as the precision you require. This would be the correct way of deciding that 2 numbers, A and 6.3, were effectively the same. You never want to use equality when you're testing for floating points. Anyways, floating point numbers support a number of operations, adds, divides, multiplies. You'll notice there's no bit shifting. You can't do bit shifting on a floating point number, but there is a lot more things you can do with floating point numbers, and they are all found in the math module. So if you want to do things like a square root isn't built into the language. You can't say the square root of 81. It'll say, I don't know what is square root. But there is a module called math, and inside of math, there is a square root. There is a sine functions. Now, sine here, sine of 0, math sine of 90. Okay, if you know anything about degrees, sine, it's not operating on degrees here, it's operating on radians. How would I know that? Well, as I'm learning the language, I may want to type in help.math. It says return the sine of x measured in radians. So if we're gonna do this correctly, we probably need to do math of math.sine. I believe there is a math.pi. Should you ever require pi, there it is, just sufficient digits for floating point calculations. There's a cosine and a tan and a log. Now, for what we are doing for today, Thursday, next Tuesday, the math library is sufficient. It's built into the library. It's all good. If you're a Python developer and you do science stuff, you know about a language called a library called NumPy for numerical Python. We will get to it. But for this moment, the math library is totally sufficient. And it's got all of the kinds of things that you would expect to be in a math library. Incidentally, if you're interested in just exploring what's in there, go to the documentation, docs.python.org, take a look at the math module, and you will see all of the functions that's in there. There are inequalities, less than or equal to. My fonts are a bit weird on this computer. Let's make some numbers. X equals 2, 3, Y equals 8. Okay, X less than Y, no problem. X is less than or equal to Y is what this represents. My editor is trying to render less than or equal to in a fancy way. This is called a ligature. So it's something in encoding you sometimes have. It's just my editor is saying, oh, I know, I'll try and be pretty for you. I'll make less than or equal to this symbol. In fact, you can see that that's what's occurred here in my editor. When I go about and I actually type in less than or than equal to, my editor swaps this and makes it a look like that symbol. In fact, equals stays as that shape, but does not equal gets replaced with this cryptic symbol. Okay, X does not equal Y. If I take that line and I copy it and I paste it, it suddenly becomes this. That's my editor representing the sequence of characters, :0 as this symbol. It just makes my code a little bit more readable, but syntactically, it's two characters. This first character is a exclamation mark, then it's an equal sign. They're called ligatures. They happen in typography all the time, and sometimes people's editors have those built in, but don't get thrown off. These are just ligatures, typing characters. So not equal to is $0. You've also got an and, an or a not. And, or not are very low in the precedence. So you can do things like saying B is greater than or equal to A and B is equal to C. You don't need to wrap these things in brackets because they're low in precedence. This will get evaluated and this will get evaluated first. But because of precedence, not B less than or equal to A, the not B would get evaluated first. So we evaluate this expression before doing it. You can convert between types explicitly with int, float, and bool, and it will try and convert from one type to another as best it can. Obviously, integers can become floats. When it tries to go from a float to an integer, it's going to truncate. It's going to try and come with the nearest integer that makes this match. And if you try and do a conversion that doesn't make any sense, okay? So let's say I had this as my value, okay? And I say int of A, it goes invalid literal int with base 10. It goes, I have no idea how to turn the letters Z-E-R-O into a number, okay? It's trying, but it doesn't know how to do that. Now, it could take a string, and you could say int of A, and it will try and turn the string 1, 2, 3, 4 into the nearest integer that it can. Okay, exercise number 2 of the day. We're going to be doing this always in the work directory. Look for a file called mortgage.py. And here is a program that is going to calculate a 30-year fixed rate mortgage of $500,000 with Guido's mortgage stock investment in Bitcoin trading op corporation. Guido, again, is Guido van Rossum, the inventor of Python. And of course, this is a nod to the way world is currently working. Okay, so let's do this. Let's look through this piece of code and see what it does. We'll do this all together. I'm always inside the work directory. There is already a piece of code called mortgage. So I'm going to open up that file. I'm going to edit it. I'm using VS Code, which allows me to have multiple windows here so I can see the code and the text. And so here is a program that does this, right? So this is Exasol 1.7. Well, how does this work? Okay, well, how it works is we've got a variable, which is a principal. Okay, let's say $500,000. I'm putting the .o here to make it explicit that I want this to be a floating point. The rate is 5%. Let's say I am paying this thing down at $2,684.11. And I want to figure out how much money I have paid back. We have a loop. So while you have any principal remaining in your account, the principal is going to go up because of principal is going to go up because of principal, because of, pesky things like interest. And this is a per annum rate. Okay. So this is a 5% per annum per year. I'm going to go up 1/12 of that because I'm basically going to look at monthly payments. The principal is going to increase by that much, but then go down by however much I pay my mortgage every month. And then I can figure out how much money I've totally paid all the way through. Paid plus payment. Oh, I'm seeing something here. Well, that's weird. Okay, all still good. Okay, and then we can summarize our product, our program. Total paid, total paid. Okay, so now we've got our program written out there, and you're right, you can copy and paste it if you want. Let's run our program, Python mortgage. Okay, total paid, blah, 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 blah. Okay, so a couple things about this. Here is a version of the program that's doing that. You should get an answer of 96272.6. You're getting this because this is the floating point representation of the answer. Yes, in practice, we would say this is 60 cents. What we can do is we can ask a program to format this string so that it looks like the way we're supposed to do it. I don't know if it's going to talk about this later, but I'm going to talk about this right now. There's a nice way of formatting strings, which is to use what's called F strings. So this is a feature of newer versions of Python, and there are other ways of formatting strings. By default, print will just put something, it will add in its own space, and then put the next thing. And every time you put a comma, it will put a space in the next thing. What you can do is you can take a string, and the strings are by quotes, wrap this thing in curly brackets. Okay, so if I run that program, it's going to just say the word total paid. But if I put an F in front of it, what it will do is take this string and replace whatever total paid is with the contents of that variable. Now, so far, that's nothing new. But where it gets cool is I can do what's called a format descriptor or some way of explaining how the format wants to go. So what I can do is I can say total paid is represent this thing as a floating point number with 2 decimal places. And if I run my program, I am forgetting what the syntax is on this one. Why is my brain? No, that's not right either. Format specifier. Why is my brain working for format specifiers? What am I doing wrong? Format specifier. It's the same thing as in Python. And I'm just float. No, I want F strings. I want F strings. Come on, give me an example here, Web, because why am I? Oh, right. It's just the order. Ha 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 ha. Different languages, different things. 0.2, then an F. Okay, so this is saying take this expression and render it with 2 decimal points as a floating point number. Okay, and the benefit here is you're able to make it look like the way you want it to look. There are other ones if you really wanted an exponential notation. What am I doing? Go away. Wrong program. I could run this and say run this thing's exponential notation, but it's a nice way of making it look correct. That's exponential notation. We wouldn't want that for finance. So we may want to have a string that looks more like this guy. There is some way of getting that parenthesis, that semicolon in there, but I would have to look that up. But there is some format trick. Not that I'm going to be able to remember it right now. No, wasn't that one. I'd have to look it up in the documentation. I won't bore you guys with that. Okay, so there's an example of a program. So hopefully you've run that and you've got it to work, and it's an example of doing floating point arithmetic with a program. Okay, so here's our modification. Okay, the exercise is to take this program and modify it so that Dave is paying an extra $1,000 a month for the first 12 months of the mortgage. Okay, confirm that over the lifetime of the mortgage, he's now going to pay a little bit less money over that amount of things. So the way we're going to do this exercise is we're going to take this version of the code, we're going to add it to our staging area, we're going to commit it, and we're going to say mortgage after exercise 1.7. Okay. So I've locked it in. I've got a version of what this thing looks like at the end of exercise 1.7. And now we're going to tackle 1.8. Okay, so the scenario goes is you're going to go up here and you're like, okay, I'm now going to modify this and make this the solution to 1.8. Okay, so what do I need to do? Well, I need to have some idea. Well, I'll bring this up, but we'll just do some live coding here. What do I need to add to this program? So that I could track the first 12 months of the mortgage. I'm just looking for someone's mic to go on. Oh, you're all quiet. No one's willing to jump forward. See, in a classroom, I could point to someone. Oh, you're all silent. You need to add. Oh, yes.
Yeah. So here we are said that they need to pay extra 1,000 by month for
the first 12 months. Yeah.
Yeah. So for the principal, I think you need to set up a condition.
You need a condition. Yeah.
Yeah. So suppose if something less than 13, I think.
How about less than or equal to 12?
Yeah, that should work.
Yeah, okay, so make it more readable. Yep. So something less than equal to 12, what should happen?
And then again, we can do the principal thing here.
Yep.
The principal is equal to the whole line, I think, minus 1,000.
Okay, so here's the question is what are you going to compare that to?
Yeah, so what I can do here, I can declare a variable outside the loop.
Yep.
Like I is equals to 1.
Okay, so here's something about programming. I is an absolutely terrible variable name.
Yeah.
right? Okay, you know that's terrible variable name. Give me a better variable name.
Count.
Count is slightly better, but still poor. What are we counting?
Okay. The months.
Exactly.
Yeah. So
okay. So while the
if
months is less than 12, do this.
Yeah, and we need to increase the month by 1.
Exactly. Right.
I think it should work.
Okay. So you see how we got that structure? And now, of course, we test it. Now, this number is not quite the same as this. And this number is not quite the same as this. Okay. So there is actually still an error in here. It's not quite right. Okay. So it has to do with your initial conditions and when you end this loop and where these lines are occurring. Okay. So I will leave it to the class to fix this so that you actually get this number out. When you've done that, do an add and do a commit, and that's exercise 1.8. The only other modification I would make to this is, right? Generally, your programming should have variables right? So you probably want to do things like that when you're coding, right? Make it really explicit what the 12 and the 10 are going through. So I will leave it for you to work on over the next couple days, exercise 1.8. I will leave it for you to do exercise. So the idea is to get this to work so that it spits out the correct number. Once you got it working out, you commit, you save it, you do it. And now we're going to modify this again. We're going to say, okay, we're going to modify this program so that information can be more generally handled. Okay, I've already got extra payment. I added that in here. What they're saying is, you know what? Maybe you're not going to pay for the first 12 months, but you're going to pay for month 61 to month 108. Okay, and try and see if you can modify this program to have that functionality. Once you've got that working, add it, commit it, and then do the next one, which is, okay, let's print out a mortgage table, right? And make this all work out. Okay, so this is the idea of investigating this. It's not so much calculating your mortgage, it's playing around with what constructs within Python we need to make this go. Okay, so I think that's getting close to plenty for today. I'm going to leave you with, and you don't need to do it right now. You can be like, I've been in front of a screen for 3 hours. I'm done. Go away, but at some time later on, tomorrow, Wednesday, complete these exercises. Okay, and the idea here is to go through them. And what I'm looking for is in your Git history. We've all supposed to have forked this, right, from David Beasley's course. You each have your own account. You're not supposed to fork it from mine. You're supposed to fork it from his and have your own version. It's public. And as you're doing these exercises, you're committing. So once you've committed a bunch of stuff, you're going to push it. And this is basically assignment number 4. This is me watching you work through these exercises. So if there's an exercise that is just, that has no code associated with it, it's just like, try this on the command line. I don't need you to do anything. I'll trust you that you've done it. But if the code says, like, modify this program, then commit the program. But here's an example. Mystery, right? Here is something we want to do, right? Can you explain this thing? There's no code to commit. You can just answer this for yourself. I don't need you to write down an answer, but just go through it. Think about why bool of false would give true. Right? And that's a little puzzle. and we could talk about it some later time. Okay, so we're just going through learning at the basics of Python. On Thursday, I'll continue on. I don't want the README. I've lost my notes. I've lost my notes. Introduction. We'll do some stuff with. Oh, no, preview. Go away. We'll continue with some stuff on text and lists, files and functions. Okay, and my guess is that's going to be about the first hour and 20 minutes of Thursday. Then we're going to take up the Git assignment just to make sure we've all done it. And I'll ask some people to sort of talk about Git for a few minutes. And then we'll get into this next unit and talk about data structures and formatted output and sequences and list comprehensions and objects. So slightly more advanced Python stuff. In terms of what I want you to do with this material, as you were working through it, I said we'll get to Unit 2 next time, but you already can do everything from the first 1, 2, 3, 4 sort of steps. You can keep on working ahead if you're comfortable doing that. That's fine too. Stop share screen. I will just share. I'll share the whole screen. Share the whole screen because what I want is I'm on login. Waiting. Here's the course. Course content. I will draw your attention to the fact that I've put up an assignment 4. Okay. The due date is roughly a week from today. But it has the instructions I just went over. The expectation is you have the course material forked from the original repo. You're just doing all of the exercises. I believe there's one exercise which is actually missing. So I think 1.13 just doesn't exist. Maybe it's 3.13. Doesn't matter. If it's just asking you to try it, don't bother doing it. Anytime it asks you for a Python file, put it into your work directory, commit those exercises. I said commit early and commit often. And then once you're all done that assignment, fire me off a note in Slack saying, hey, James, I'm done assignment 4. And I will just go peek at your GitHub directory and look at the history. And if I see a bunch of commits, I'll be like, yeah, you did this. If for some reason you get stuck, remember that there is a solutions directory, but you're not supposed to just copy and paste the solutions directory. That would be a waste of everyone's time. Go ahead and come up with your own original solution if you could think about it's better. This is just to explore it. This is all the Python we need to cover in this course. If it's quick and easy for you, great, just get it done. If you'd like other resources for Python, I've got other recommendations if you want to deal into it. We're going to do this for a couple days so that we have a working functional knowledge of the language so that we can apply it to some libraries and do some more data analysis and scientific computing using Python. But that's basically where we're going for what we did today, Thursday, and next Monday. And with that, I think it is time for everybody to no longer stare at a screen for a few minutes, or at least not stare at me for a few more minutes. Any follow-up questions or things we want to talk about? Okay, all. Have a great one, and we'll see you in a couple days.